All right, one last time, we have a belt drive here. And again, a reminder, we have gear ratio over 1 is equal to teeth, if we had teeth, output over input. We don't have teeth here, but oh well, I already wrote it. Diameter output over diameter input. Torque output over torque input. And the only one that's flipped is the RPMs, or the omega, or angular speed input over omega output. Okay, so we are given the crankshaft, so that's got to be our input. The crankshaft's going to drive it, so that's my input, and that is my input for my diameter. So we have di and we have omega I. All right, diameter of the alternator pulley is 3.8 inches, so that is going to be do, and we need omega O for what RPMs. So we need the output RPMs the alternator pulley over here is going to get. So we're going to get our equations that we need. So we have omega, how'd I do? Nope, didn't get the whole thing. Omegas, nope, not again. Let's try it one more time. I want to show how cool I am. Okay, darn it. Oh well, close enough. And then that's going to be equal to the diameters. So, hey, there we go. All right. I'll erase that because I'll make it look like it's a negative. So that's what we got so far. And we need to solve for omega O, output omega. So we'll do a little cross multiplication here. So we have omega I di is equal to omega O do. We need omega O, so we're going to divide both sides by do. Yoink, yoink. And there we go. We get omega I di. So the output RPMs will be equal to the input RPMs times the diameter input divided by the diameter output. Plug in our numbers. We have 3893 are my numbers. 3893 times our diameter input, which was 8 inches, divided by 3.8 inches is my output. All right, so I have 3893 times 8 divided by 3.8, and I get 8,196, if I round up, RPMs. And there you go.